Good evening, my dear NEET warriors. Welcome aboard. The time is 8 o'clock and it's time for the next day of your challenge. We are already, completed so many questions in this 7 days challenge where we are going to do 1,000+ questions. Every session, 50 questions of every subject, and every day you are having 3 lectures. So that's a power-packed series, one of the best series, which I would say for all the NEET aspirants, because you're getting quality questions, very different questions from our RNA, Super 6 or any other series that you would have seen. And these questions are based on the new pattern, the challenging pattern, which will be set by NTA for your upcoming NEET 2025. So let's get started. Yep, I hope you're all excited with your master teacher for physics, your Captain Shreyas. And do me a favor by smashing that like button. And if you've forgotten, yeah, I need to keep reminding you, subscribe to the channel. Yes, of course. I was just seeing 40 to 50% of the students just keep watching our videos regularly, but they forget to hit that subscribe button. So quickly do it now for the #1 NEET English channel. And of course, mark your attendance by liking the video. Hi Pratibha, Warrior Pandu Krishna. Hi Siva, good evening. Happy evening, happy evening. Hello Ali Zug, good evening, my dear warriors. Hi, hello Ashok. Good evening, Siva. Nice to see all of you down here. And for the next session, and in this particular thermal physics, let me tell you, we're going to do heat transfer, heat and temperature, the laws of thermodynamics, kinetic theory of gases, as well as your calorimeter, temperature, thermal expansion, and all of that. So all these things come under thermal physics, the entire heat, temperature unit, okay, altogether. It definitely carries a significant weightage, and the best part is the theory is very limited and the concepts are relatively very easy to understand, and some of the concepts also get repeated in chemistry. So definitely a must do unit if you are very serious about NEET 2025. So let's start with the first question on your screen. Which of the curves in the diagram represent Celsius and Fahrenheit graphically? Very straightforward, but let's see how many of you get it. I want the spam from everyone. Hi Krishna, hi Tejus. Nice to see you guys back. Hi Mrudula. Welcome aboard everyone. Okay, let's see. Come on, my dear students. What do you think is the correct answer for this? A, B, or C, or D? One data point which you should know is that 0 degree Celsius is nothing but 32 degree Fahrenheit. So 0 degree Celsius. So Celsius 0, 32 positive. So it is over here. As you can see, this is on the 0 Celsius, but this is 32 degree Fahrenheit, correct? And temperature wise, obviously, this is on the 0 degree Celsius line. Oh, so it should be either C or A. But one thing is very obvious, that when Fahrenheit and Celsius you compare it, obviously, if the temperature in Fahrenheit goes up, Celsius also goes up. That means the slope must be a positive value. So out of C and A, obviously A has a positive slope, C has a negative slope. So if this has a positive slope, the graph should be option A. Yes. How many of you said A? Let's see. Oh, ho, 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 ho. No, 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 no. It is not C, it is A. Be very, very careful. Yeah, because yes, you will make a blunder over here that will give you a definitely wrong answer. Obviously, when temperature reading in Fahrenheit increases, Celsius also should increase. It should not decrease. So it should be a positive slope. It can't be D also, it can't be C, because even D graph has a negative slope. Got it? Understood? Everybody? Everybody made a common mistake. I know you guys love me a lot. Option C is your favorite option. Even my option is option C, right? Because the love for Capto should continue. But yeah, AIMS, A for AIMS is the correct answer. Moving on to the next one. A cylindrical metal rod of some length is shaped into a ring. There is a gap. On heating the system, what exactly do you get? Very interesting. All right. So what is X and what is D and everything? So first of all, let me tell you, this is the radius. Okay. This is basically D, and this is basically X. I think it did not get printed for some reason. Okay, I think now you should be able to answer it. Okay, come on, my dear students. D is the thickness, R is the radius, X is the gap. If you heat the ring, thermal expansion. Thermal expansion, the property is, if you have any solid, if you have any solid, if you have any solid and you heat it, then when it becomes big, whether there is a hole in it, there is a gap in it, it's a curved, doesn't matter. The distance between any 2 points increases. As temperature increases, the distance between any 2 points will increase. So if I consider the distance between this point and this point, this should increase. The distance between this point and this point, the diameter, that should also increase, so radius will increase. If I take the distance between this point and this point, even the thickness should increase. So everything will increase, hence the answer is C. Lot of people think, oh, the gap will become small because the ring is trying to expand. Don't think like that. Think this way. If there was that missing part, then even that would have expanded, and that missing part would still fit in that ring. So even if I heat that missing part independently, it would expand and still it should fit in the gap. That means the gap should also expand. Getting the logic? So any 2 points, the distance will increase when you undergo thermal expansion. Yeah, it is not A. See guys, now the love for Capto should have come. Where is your love for Capto? When the answer is A, you are saying C. When the answer is C, you are saying A. Okay, so the correct answer is option C. Interesting. Loving the question, how the questions are coming like bouncers, googly. They're trying to knock you out, and this is what is very important in the final days. There are right now lakhs, not thousands, lakhs of students who are just sitting and reading theory, and they are not solving problems. So don't worry, their competition is not for you. In fact, they are already out of the competition because they are just sitting and reading the theory and just watching theory lectures again and again, because it is very pleasing, because you don't have to do much. But when it comes to problems, that is where the hard work lies, and that is where only thousands of students will be doing it. I'm not even saying lakhs, thousands of students only, tens and not very small thousands, but a decent chunk only will be doing it. And I think you are one of them because you are watching this video. And keep it up, because all these concepts will only get cleared in problem solving. So next question, very similar type. Four geometrical figures are there. This is some angled, this is some circle with a line on it. There is a hole punched in a disc, and there is a ring with a gap. In all of them, mark true or false. The angle will not change when you heat it. The length of this line will decrease. The radius of the inner hole will decrease. The distance between the gap will increase. What do you think will be the correct one? All right. Easy, please check out the strategy video which I just made just day before yesterday. Please check it out. It will be very helpful. Okay, so many of you are saying option A. Let's find out. See, what will happen? This length will increase, but this angle will still remain the same. So definitely this is a true statement. I mean, the angle will not change. That is perfectly fine. It will just increase linearly. It will not expand like that or contract. Okay, the distance between these 2 points, obviously it should increase. In thermal expansion, the distance between any 2 points on that solid should increase. It says decrease. So second one is false. The radius of the hole will decrease. No. If you take any 2 points, the distance should increase. It says decreases. So third is also false. The distance will increase between that gap. Yes, this point will go here. This point will go here. The gap will definitely increase. So true, false, false, true, which is option number A. How many of you wrote option A? Very good. Excellent A. Now your aim's dream is true. See, this is what happens when you have solved similar questions, how you gave the question's answer correctly. See how much difference it made solving just one question. So guys, that's what I'm trying to tell you. When you solve these 1,000+ questions, imagine 1,000+ mistakes you will be avoiding. You are already 1,000 steps ahead of those students, lakhs of students. And it is not 1-2 lakh, it will be more than 10 lakh students who are not even your real competition. So guys, you should be proud you are solving problems. Moving on to the next question on your screen, here it is. The ratio among the linear expansion, areal expansion and the volume expansion is 1, 2, 3, 4, 3, 2, 3, 2, 1. None of these. Come on. Very good, Pratibha. Hi, Percy. Very good, Krishna. Warrior Pandu. All right. J 2026 batch. Yes, we have the pro batch and I'll be making a video for that too for all of you. Okay, come on, guys. Let's see if you guys can answer this particular question. 1, 2, 3, 3, 2, 1. What do you think it is? Alpha, beta, and gamma. We know gamma is 3 times of alpha. We know beta is 2 times of alpha. Obviously, then, if you take the ratio of gamma is to beta is to alpha, gamma is 3 times of alpha, beta is 2 times of alpha, alpha is 1 times of alpha. Alpha, alpha, alpha cancels. So you will have 3 is to 2 is to 1, 3 is to 2 is to 1, that is gamma, beta, alpha. Therefore, alpha is to beta is to gamma will be 1 is to 2 is to 3. Exactly reverse order. So 1, 2, 3 is the answer. Very good. Awesomeness. Option A for AIMS. Excellent. Moving on to the next question. Assertion reason based. In an isothermal process, all the heat energy supplied to the body is converted into internal energy. According to the first law of thermodynamics, heat supplied is delta U plus the work done. What do you think about these statements? Whether they are both true, whether one of them is false, whether they are explaining if both of them are true. What do you think about it? According to the first law, heat is internal energy plus the work done. This is absolutely correct. There is nothing wrong in it. Remember, this is physics where the sign of work is slightly different. So in physics, this will be definitely correct. In an isothermal process, what happens? In an isothermal process, obviously, delta U will be obviously 0 because the temperature is going to be constant, no change in the internal energy. So what will happen to the heat? All the heat will be the work. So all the heat energy supplied to the body is converted into internal energy. Wrong. This should have been work. This should have been actually work, not internal energy. So obviously delta U is 0. It is the work which should have been there. Assertion is false, but the reason is true. So is it Delhi? D for doctor. Very good. Awesome, Tejus, Pratibha, Krishna, Chandresh, Alzuru. Very good, Valvan, Siva. Awesome, guys. Really cool. Kudos to all of you for answering it correct. Very good, Sai. Sai Saranya. Very good. Awesome. Perfect. Let's move. In this particular process, A, B, C, A, pressure, volume, everything is in SI units. As you can see, what is the heat given to the gas? It's a cyclic process. So there is something about cyclic processes which will help you. Remember, in a cyclic process, internal energy does not change as you come back to the original state. Its delta U is 0. So whatever heat you have to calculate will be the work, because delta U when you come back is 0 and work done is basically the area which is enclosed. The area which is enclosed. Well, this is a triangle as far as I can see. So half multiplied by the base BC. This is basically your base, and obviously the base is 1 unit, so I'll put 1 over here, and obviously this is nothing but the height of the triangle. 2 and 4, height is 2, so I will put 2 over here. Half base into height, 2 cancels, so 1 joule is option A for AIMS. Perfect. Very good. Many of you have got it, I guess. Yes, all the heat is basically going to get converted to work. So if you want to calculate work, calculate the area. There is no use of internal energy because you are coming back to the original state. So that's your cyclic process theory being directly used there. Awesomeness. Let's move to the next question. Looks like a graphical question again. The process is equal to 0 for an ideal gas can be best represented in the form of a graph. Choose the correct graph. I think something is missing over here. Something is missing, guys. Yeah, I think some word is missing over here. Either work done or maybe heat or maybe something like that. See, If the answer is, or rather if the question is work done is 0, that means it will be isochoric process. That means it will be isochoric process. Then it will be option C. Then it will be option labeled C. But let's say it is delta U is equal to 0, then it is isothermal process. Isothermal process. So the graph will look like a curve. So then it will be basically B option. If heat is equal to 0 is mentioned, then it will be adiabatic as the answer, adiabatic process. Adiabatic graph is also going to look like a curve. Still the answer will be B. So depending on what is 0, that will be the answer. So if B is given, most likely the heat was 0 or delta U is 0. So I'll just put that over here. Most likely it was the heat which was 0. I think that symbol did not get printed. But I have given you all the three answers in case of any of these three questions come. Okay? Is that clear, everyone? So depending on what is 0, your answer will definitely change. So moving on to the next one, again a graphical question. There is a pressure volume graph. The work done by the process in A to B to C to D is how much? Very interesting, guys. It's not a cycle. Yeah, it is not a cycle. Yeah, if it was isobaric, somebody is asking, sir, what if it was isobaric? Yes, if it was isobaric, then this will be the graph. Yeah, if it was isobaric, then pressure will be constant, of course. Yeah. What about this? You have to be little bit careful over here. See, guys, in this part of the graph, A to B, the work done will be negative because your volume is decreasing. Do not forget that. So, this work done will be height, which is nothing but P naught, into the base, which is again V naught, but negative because of compression. Because of compression. In case of compression, the work done by the gas is negative. Next part is this B to C. It is basically isochoric. If it is isochoric because volume is constant, the work done is obviously 0. So completely ignore that. The last part is over here from C to D. That is this complete area, guys. This is one big area which you have to take. All righty. So this area is height, which is nothing but 2p naught multiplied by the base, which is also again 2v naught. This will be positive because this is expansion. This is expansion. So that is just going to give you 4p naught v naught. But the question is something else, the total work. So the total work done will be minus p naught v naught plus 4 p naught v naught. So this will be 3 times of p naught v naught. So 3 times of p naught v naught is C for Captain Shreyas. Yes, your Captain Shreyas. Correct. Excellent. A. No, Tejas, it's not A. All right. So this part is 4. This part is minus PV naught and this part is 0. So add this. That will give you the total work. It was not a cyclic process. Mind it. Okay. Clear? So that is how your game has to improve. You have to slowly practice newer model of questions. When you practice now these things in the exam, in the mock test, when this similar question comes, you will know how to solve and you will get that confidence. Next one on your screen now. The PV diagram, ABC is a semicircle. The work done in the process A to B to C is how much? Interesting, guys. A to B to C. Well, if you notice in this particular process, okay, in this particular process, A to B, the work done will be negative because your gas is compressing. Whereas from B to C, the work done will be positive because the gas is expanding because of expansion. So when you want to find the total work done, when you want to find the total work done, it will be the positive work and the negative work subtracted. So that will be only this particular area. That is this particular area. And I can see the positivity is more than the negativity. So it is just going to be that positive and the area of the semicircle. Area of the semicircle. That's it. And why is it positive? The reason for its positivity is because the positive work is more than the negative work. That's why the total work is positive. Is that clear? Okay. So what is the area of that semicircle? It is pi into radius square divided by 2. So pi by 2 is there. And what is the radius? Well, the radius is just going to be 1. So it is just pi by 2, guys. So pi by 2 is option B. Minus was also there. Many students will make a silly mistake and might answer the C option. But the answer is biology, B for biology. Very good, Pratibha. Very good, Krishna. Siva. Clear, I hope. Yep. Is that amazing question? Yeah. Again, this was incomplete cycle. Whenever cycles are incomplete, you need to be careful about the positive and negative signs. Expansion, positive; contraction, negative in physics. In chemistry, it's exactly reverse. Okay. A diatomic gas with rigid molecules, that means vibrational degrees are not counted, does 10 joules of work when expanded at constant pressure. Okay. What would be the heat energy absorbed by the gas in this process? So W is given, Q is asked. W is given, Q is basically asked. Yeah, I hope this is fine. All right. So let's try to do this particular question. Sir, it is an ellipse. Which one is an ellipse? This one? How do you say it is an ellipse? Okay. Let me see whether it is an ellipse or not. As you can see, this is particularly the diameter. This is nothing but the diameter of that circle or semicircle. The diameter will be basically 2 units. That means the radius will be 1 unit. This is the center. This is the circumference. So obviously, this is also the radius. So the radius is 2 minus 1, which is 1. So height wise or length wise, the radius is 1. So it is not an ellipse. It is a semicircle. Oh, sorry, it is a circle. Is that okay, Siva? Fine. All right. So what about in this particular case? Since the work done is given and the work done formula, work done is 10 joules, work done formula is just P delta V. Work done formula is nothing but P delta V for constant pressure. It is clearly mentioned. P delta V is nothing but 10 joules. But what do we do with this? P delta V is nothing but NR delta T. NR delta T is therefore 10 joules. Just leave it aside. We can't do anything more apart from this now. Let's think about the next part, heat absorbed by the gas. So heat absorbed by the gas. What is the formula for it? It is nothing but NCP because it is constant pressure delta T. CP, but what kind of gas it is? Diatomic. For diatomic, what is the value of CP? 5R by 2, that's mono. 7R by 2, is that right? So that is going to be 7R by 2 delta T. Oh, I got an idea. NR delta T is right over here. So why not put 7 by 2 and just NR delta T over here? So it will become 7 by 2. This particular NR delta T, deliberately I wrote it like this so that I can substitute 10 over here, and 10 goes with 2 5 times. So 7 multiplied by 5, which is 35 joules. So that was a very good manipulation which we have to do. Now you'll be like, sir, how did it even strike you that we have to do this? The reason is I have solved many problems. That's why it struck me that I have to do this. But otherwise, I cannot think on the spot if you have not solved many problems. So that is the reason why you have to practice, practice, practice. So when work is given, heat is asked. Heat is given, delta U is asked. Delta U is given, work is asked. So such kind of questions, usually this manipulation is there of NR delta T, which you can then use for the other problem, other variable. Specific heat of a gas at constant pressure is greater than its specific heat at constant volume. That is the truth ultimately. CP is more than CV. Everybody knows this. Okay. But is the reason correct? At constant pressure, some heat is spent on the expansion of the gas. This is perfectly correct. And it is also explaining it properly because when you heat something, it expands. When you heat something, when you heat something, it obviously will expand. It will expand. So whatever heat you give, whatever heat you give will go into the work and increasing the temperature. So doing that work and increasing the temperature. So you need more heat when you are trying to change the volume also at constant pressure. But at constant volume, you don't have to worry about expansion because the volume is constant. So all the heat goes in changing the temperature. So that is why CP is more than CV. So it is the correct explanation for it, and hence option A. Very good. Excellent. Vandana, after a very long time, I'm seeing you. I hope everything is fine on your end. Okay, let's move to the next question. Wow, what is this? The slopes of isothermal and adiabatic direct theory question. Direct theory question, guys, you should know it. Yes, the slope dp by dv, the slope dp by dv for isothermal and for adiabatic, what was it? dp by dv. If it is isothermal, then it was minus P by V. If it was isothermal, if it was isothermal, and that same slope of dP by dV was minus gamma times P by V if it was adiabatic. If it was adiabatic. So clearly, dP by dV, which is the of adiabatic, slope of adiabatic. If you just take that gamma outside, that negative P by V is nothing but the slope of isothermal process. The slope of isothermal process pressure volume graph. So slope of adiabatic is gamma times the slope of isothermal. C option is the most appropriate option. Very good, Krishna. Chandresh, Alizu, Vandana, I am very good. I am great, fully busy in the exam season, and I hope you too are busy in this particular exam season. If you are saying life is cool, then some problem is there. But if you say life is sir problematic, sir full tension, then everything is fine. Don't worry. That is exactly how it should be at this point of time if you are a NEET aspirant. Okay, everybody is worked up, everybody is nervous, everybody is tense because NEET is around the corner. So perfectly normal. Okay, just go with the flow, everything will be fine. Just practice and stay focused. Temperature of 2 moles of a monoatomic gas is increased from T to 2T. Match the following two lists. Oh, 2 moles. My God, this is going to be a lengthy question, guys. This is going to be a lengthy question. We have to check many things, but you can play it smart and see which is the most common or uncommon question. A is going with RQRP, BRSS, SPQS, RRSR. Okay, D, I don't think I will check first because, sorry, this is PRSR. Okay, any one I can start with. So, monoatomic gas temperature is increased. So, in the fall, isobaric is there, internal energy is there, work done in adiabatic is there, change in internal energy in the adiabatic process, so many things. So internal energy calculations are usually the easiest. So go with delta U. Delta U, no matter what, whether it is whether it is adiabatic or isobaric or isochoric, delta U, the formula is always the same. Delta U is always the same. It is NCV delta T for all the process. For all the processes. What is the moles? 2. What is CV? It is mono. Mono means gamma will be how much? Mono means gamma will be how much? 5 by 3, correct? And CV will be nothing but 3R by 2. CP will be nothing but 5R by 2. Okay, so put over here 3R by 2 delta T, T to 2T. So therefore, this will be 2T minus T. So 2T minus T is T. So 2 cancels. So it will become 3RT. Just check it out. Is it 3RT, everyone? Yes. Okay. So our B option as well as D option should be 3RT, which is nothing but P. Which is nothing but P. So this and this both are P. B and D is 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 P. Oh, I can see it only in one option, guys. B is P. D is P. Can you see that? B is P. D is P. That's it. Done. Dusted. I will move on to the next problem. Solved. Option A. That is how toppers will work in the exam. That is how I will also give the NEET exam. I will not sit and check. Oh, I have to start from option A. I am sincere student. Oh, option A, sir, work done from isobaric process. Oh, sir, I got R. Sir, R is there. No, R is there here also. Oh, shit. I have to check one more option. Waste of time. Play it smart. See internal energy, just checking that, solve the problem within one go. You don't even have to check the others. Got it? How to play it smart in the exam? So as we are solving, we are seeing how to exactly attempt in the exam also. Other things are also straightforward. It is not that difficult at all. So say for example, you have to find the work done in any case. So work done for isobaric process will be nothing but P delta V, which is nothing but NR delta T. So again, to find out the work, you have to find out the heat or the delta U. From that, you can find this out. Okay. So you can use this. Then actually the moles are given, you don't even have to do that. So this N will be 2, R is R, delta T is 2T minus T, which is T. So this will be 2RT. So work done will be nothing but 2RT. So for A, for isobaric process, 2RT, which is basically R. So A will be basically R, as you can see. Same thing you can do for adiabatic process also. Moving on to the next one. In the following PV diagram, two adiabatic and isothermals are given. This is like a heat engine kind of a graph anyways. What is the value of VB by VC? This volume by this volume is which volume by which volume, or more than or less than? I think it is straightforward. I'll tell you why. I think this is isothermal because temperatures are constant. So can you see? I hope you can see this. This is at temperature 1. This is at temperature 2. These are the two isothermal graphs. And for isothermals, because the temperature is constant, pressure into volume is definitely a constant. Pressure into volume is definitely a constant. Okay, number one. Also, can I somehow compare their volumes now? VB by VC. VB by VC. Can I say they are comparable with something? Think about it. Think about it. Yes, temperature is the same here and here at A and B. Temperature is same at A and B, and temperature is same at B and C. So between A and B, between A and B, can I say between A and B, PA VA is equal to PB VB? So therefore, PA by PB will be VB by VA. Will be VB by VA. Is that right, everybody? Yes, awesome. Similarly, between D and C, what can I tell? I can say PC VC will be PD VD. Okay. So from this, I can say that VC by VD will be PD by PC. Okay. Now I can see VB here, VC here, VB here, VC here. So is there a way to compare them? Is there a way to compare them? Now that can happen only if I am able to, yes, only if I'm able to compare the, if I'm able to compare the pressures somehow. But can I compare the pressures, you might ask? Can I compare this pressure and this pressure? Can I compare this pressure and this pressure, you might ask? Well, these are adiabatic graphs, so I have to make use of that information also. I have to make use of that information also. So A to D and B to C, basically they are adiabatic graphs. So therefore, PV raised to gamma is constant. So how about saying PA VA raised to gamma is PB, sorry, not PB, PD VD raised to gamma. All right. So now from this, I get VA by VD whole raised to gamma is PD by PA. That's all. VA by VD whole raised to gamma is PD by PA. Similarly, between B and C, I can say PB VB raised to gamma is PC VC raised to gamma. So therefore, VB by VC whole raised to gamma is PC by PD, is nothing but PC by PD. Okay, just check it out, everybody, with me till this point. Clear? Yes. Till this point, everybody clear? I have just written down the equations. I just written down the equations for, yeah, I just written down the equations for your adiabatic and, yeah, adiabatic and your isothermal processes. Correct. Very good. Sir, please check the previous question. Tejus, oh, is it one? Just 1 second. Let me go back to the previous question. After this, hold on. Okay. First of all, what do we need to do over here? Now, as you can see, VB by VC is there right over here, which is nothing but PC by PD. PC by PD. Can I get PC by PD from somewhere? I think right from here I can get it. PC by PD is there right over here. Oh, sorry, this was B, my bad. Not D, this was B. If I want VB by VC, if I want VB by VC, here you have PC, here you have PB. Here you have PC, here you have PB. If I divide both of them, if I somehow take care of both of them, then maybe I'll get a relationship of PC and PB right over here, which I can substitute in this particular problem, which I can then directly substitute in that particular problem. Okay. So see what I'm going to do. Just let's just let's take this and just divide both of them and see what do we exactly get. Okay, so PA by PB, divide it with this. So you have PD over here and PC goes on the top, will be equal to VB by VA is as it is, and divide it with basically VC by VD. Okay. Now I can see PC is there, PB is there. I can see PC is there, PB is there. Wow. I can see PC is there, PB is there. So this PA and PD, maybe I'll take it over here. This PA and PD, maybe I'll take it over here in the next step. So this will become PC by PD will be VB by VA into VD by VC. This PA and PD goes on the other side. This will look like PD by PA. This will look like PD goes on the top, PA comes below. Okay. So what do we do about PD by PA? It is there right over here. It is VA by VD whole raised to gamma. Okay. So this will be nothing but VB by VA. This will be VD by VC. PD by VA, sorry, PD by PA will be VA by VD whole raised to gamma. This will be VA by VD whole raised to gamma. VA by VD, VA by VD whole raised to gamma. So I have found out the value of PC by PD is this big thing over here. Just substitute now. Just substitute this entire thing over here, guys. You are going to land up with the answer. So this will be VB by VC whole raised to gamma is equal to, instead of PC by PD, put this big number, which is VB by VA, VD by VC, and then you have VA by VD whole raised to gamma. Now you'll be like, sir, this is getting even more complex. No, few more steps and you're going to get the answer. You want VA by VD somehow. VA is there, VD is there, VB is there, VC is there. Take it on the other side. So this will become VB by VC whole raised to gamma. VC goes on the top, VB comes below is equal to VA by VD whole raised to gamma, and VD is there over here and VC is there over here. Interesting thing to see that I am getting VB cancelled over here, so gamma minus 1. So VB is also gamma minus 1, and so is VC getting cancelled over here. So by VC, whole thing raised to gamma minus 1 is equal to, check over here, guys. Check over here. Sorry, this was A, I believe. My bad. I put C, my mistake. This was A. So this is nothing but VA and VA getting cancelled. So gamma minus 1. VD also getting cancelled. So VD whole raised to gamma minus 1. Both powers are gamma minus 1. So VB by VC, what does this tell you? VB by VC should be equal to VA by VD. Both their values should be equal. So hence the correct answer is option labeled A. Hence the answer is option labeled A. So this question very challenging, but can decide, or rather NTA might give it deliberately, saying that I don't want anybody to score 720 out of 720. And I think NTA will try to do that because they tried to do it in JEE mains also this year. So there is a good chance. Got it? Okay, great. In this particular question, the pressure was 4 atm, temperature was 27 degrees Celsius, which is 300 Kelvin. If it bursts suddenly, yes, it is adiabatic. Yes, it is adiabatic. And because it bursts, the outside pressure would be 1 atm, and P raised to 1 minus gamma into T raised to gamma should be constant. Yep, it is not P raised to gamma minus 1. Yes, it is P raised to 1 minus gamma. Correct. So this should have been 1 minus gamma, not gamma minus 1. Yep. So therefore, what you will get is initial pressure 4 and 1 minus gamma. That means 1 minus 7 by 5 into temperature was 300. 300 raised to basically 7 by 5, because gamma is given to be 7 by 5. Outside pressure was 1. So 1 minus 7 by 5 over here, multiplied by the temperature raised to gamma. Okay. So therefore, this will become 4 raised to minus 2 by 5 multiplied by 300 raised to 7 by 5. 1 raised to anything is 1 only. So 1 multiplied by temperature raised to 7 by 5. Now raise it to the power 5 on both sides. So 4 raised to minus 2 multiplied by 300 raised to 7 is equal to T raised to 7. Now take the 7th root. So 4 raised to minus 2 by 7 multiplied by 300 is equal to the temperature. So this is option D. Yes, this is definitely option D. Correct. Yep. Yep. I hope this is clear. Awesome. Loved this question. Okay. So yeah, this question was too good, right? Because we had so many equations and we had to play a lot of manipulation. Trust me, do this question once more at home, you will get that confidence. It's a jumbling of variables, but if you do it properly, you will definitely get it. Let's go to the next question coming up on your screen. Shall we? Okay. Statement based questions. The following three statements: the work done by an ideal gas during an isochoric process is zero. Okay. Yes, I think that is correct. And choose the correct options they have asked. The work done by an ideal gas, definitely it is zero. So first statement is correct. Calorie is a unit of heat. Yes, definitely. You can use calories as heat unit only, definitely. The value of the state variable depends only on the state, not on the path that you take to arrive at that state. That is the definition of the state variables. You do not depend on how you arrive. You just worry about the current situation. So like entropy, internal energy, etc. Choose the correct options. I think all three are correct. So it should be B for biology. Yes, that is the correct answer. All the three are correct. Awesome. Awesome. Perfect. Perfect. Let's move on. Yes, Vandana, I know the quality of questions is like this. 140 joules of heat is added to a gas and the change in the internal energy is 30. Then the amount of work done. This is, I think, a laddu question after looking at all these things, because Q is nothing but delta U plus W. Heat is added to the system. So this is plus 140. The change in the internal energy is 30. So this is 30. Work done is asked. I mean, that's all, guys. I mean, 140 minus 30 is 110 joules. There is nothing strange here. It was a simple, easy peasy question. Okay, so after a few difficult questions, uh, you become scared when you see an easy question. Have I done it correctly? Is something missing in the question? Nothing. It is 110. Just having to use the first law of thermodynamics. Okay, the specific heat of an ideal gas for isothermal process. The specific heat of an ideal gas for an isothermal process. Come on, guys. Very interesting question. We know about CP, we know about CV, but what about CT? They're asking you specific heat capacity for isothermal. CT they are asking, not CP or CV. So go by the pure definition. Heat is NC delta T. So if you talk about C, it will be Q by N delta T. Since we are talking about isothermal process, obviously this delta T will not change. It will be zero. So if it is negligible, not changing in an isothermal process, so what should happen to C? It should tend towards infinity. Yes, correct. It should tend towards infinity because delta T is zero. The reason being temperature is constant, being isothermal. So therefore, the answer is infinity. When C is very large, like 10 lakh, 100 crore, then you can almost take the process to be an isothermal process. Temperature is not going to change much. Very good. Awesomeness. Great. Let's move to the next question on your screen. There is a gas which goes from state A to B by absorbing this heat doing this work. Now it goes between the same two states, between those states via another process by a different heat. What is the heat in the next, sorry, what is the work in the next process? So, because it is going to the same two states from 1 to 2 with a different path, so delta U will be same, delta U will be same, and delta U we all know is Q minus W. So Q minus W will be the same. So in the first process, 8 into 10 to the power 5 joules of heat is absorbed, and 6.5 10 to the power 5 joules of external work is done. So be careful, this is external work. So work done by the gas will be negative. Be careful, this was external work. So this has to be negative as per physics sign convention. So a lot of people will miss the negative sign here and you will get a wrong answer. Okay, next part, it absorbs 10 raised to 5 joules of heat. So Q is basically 10 raised to 5 and the work done is basically asked. Great. So therefore, I can see W will be 10 raised to 5 is just a common thing here everywhere. 1 plus 8 is there over here. Minus minus is plus, goes on the other side as minus, and this will be 6.5. Is that right, everyone? Everybody with me? Okay, both the times, correct. So what is 1 plus 8? It is basically 9. Transferred between the same to say external work done. Okay, so this is basically 9 and this will be 2.5. I don't see 2.5 in the things unless they themselves have made a mistake thinking this was internal work. Yeah, and by doing 6.4 10 to the power 5 joules of external work, guys, external work, this has to be negative. You can't make that mistake. 1 plus 8 is 9, 9 minus 6.5 is 2.5. So this is 2.5 into 10 to the power 5 joules. Now, since the answer is positive, so it is done by the gas. It is done by the gas. Now, if some student would have made a mistake of not taking this minus, then the whole game would have changed. And the whole game would have changed. Okay, one mistake I did, guys. Sorry. I had to put minus 8 over there. This was 1. Take that 8 on the other side. This will be minus 8. Minus minus plus goes on the other side, becomes minus 6.5, I believe. So this will be 10 raised to 5. So 8 plus 6 is 14. So this is 14.5. And 1 minus that is basically minus 13.5. Just check this out. So technically this is minus 13.5 into 10 to the power 5 joules, minus 13.5. So if this is the case, it is negative, then it is done on the gas. If it is negative, then it is definitely done on the gas. That is what it is. Now, the problem is none of the options are matching. That means they have definitely done some mistake somewhere. Okay, number one. If you by chance miss that minus sign which is there over here, you don't put this minus, then somebody will put this as plus. Okay, so be careful. Then what will happen? This will become 1 plus 6.5, which is 7.5. So that person will get the answer as minus 0.5 then, minus 0.5. So the answer will be zero point 0.5 joules of external work is done or negative 0.5 joules of work is done by the gas. So work done on the gas will be 0.5. That is the mistake what would be done. And I think the answer marked here is done with that particular mistake only. So avoid that mistake, guys. Yes, be careful. That is not the correct answer. The correct answer is minus 13.5. So none of the options are correct. I hope this is absolutely clear. Yeah. Is that understood? So the catch in this particular problem is this much amount of external work was done. So if work done externally on the gas was 6.5, therefore the work done by the gas is negative 6.5. And in physics, we always take work done by the gas. Okay. If we take it as internal work, yes, then the answer would be B. But the question is not like that. The answer would be B if this was mentioned. This much 6.45 into 10 to the power 5 was done by the gas. If that was mentioned, work was done by the gas, then the answer would have been B. Okay, but that is not the answer now. Cool. Shall we go ahead? Such small words will make a big difference. Yes. Okay. Tejas, work done by the system is positive in physics. In chemistry, it is negative. Cool. Clear? Yeah. By the system means positive. So therefore, because this was negative over here, work is not done by the gas. This negative means the work was done on the gas, not by the gas. I hope this is absolutely clear. Shall we go ahead to the next one? Okay, great. Here comes the next one. During an adiabatic process, the cube of the pressure is found to be inversely proportional to the fourth power of the volume, and the ratio of the specific heats is. Okay, let's understand. The cube of the pressure, P raised to 3, is inversely proportional to the fourth power of the volume. That means P raised to 3, V raised to 4 is a constant. Okay, why not take the cube root on both sides? So this will be P into V raised to 4 by 3 is the cube root of a constant, which is just another new constant. How does it matter? Now compare this with PV raised to gamma. Clearly you can see the comparison. Gamma is 4 by 3. 4 by 3, guys, which is nothing but 1.33. Correct? 1.33. That is the answer B for biology. So it was just manipulation. That's all. Oh, no problem, Vandana. Yes, perfectly fine. Great. Moving to the next one. Assertion, the temperature at which the centigrade and the Fahrenheit thermometers read the same is minus 40. Okay. And it is just experimental value and there is no such relation between centigrade and Fahrenheit. This is absolutely correct. Yeah, minus 40 is the temperature. You should know it by heart only by now. You would have solved problems also. Is the temperature where Celsius and Fahrenheit are exactly the same. Is it just a random value? No, it is not just a random, it's not just some random experimental value and there is no relation between, what is this? There is no relation between Celsius and Fahrenheit. Obviously, how can you say this is correct? There is no relation. There is relation. Fahrenheit minus 32, correct? Multiplied by 5 by 9 is equal to the Celsius scale. That is the formula. There is a perfect formula between Celsius and Fahrenheit. So B is false. Reason is false. Assertion is correct. So assertion is true. Reason is false. That is C option. Yes, perfect. C option. Very good. Excellent. Many of you got it correct this time. Oops, sorry, this answer was not supposed to be shown. But anyways, consider a slab, compound one, different materials, equal length, thickness, and conductivities. The equivalent thermal conductivities. Now let's see how to solve these kind of questions. Composite slabs. So there is a slab here and very identical slab right over here too. and they are both kept one after the other. First one is K. This is basically 2K. You are going to replace it with one single slab like this. So if their thicknesses are T and T, this will have a thickness of 2T. If their area of cross section was A, this will be also A only. I just don't know what their effective K will be. K effective will be how much? Basically, what you need to do is just say the heat flow rate is going to be the same in all the slabs, or you can just say, you know, what do you say? The thermal resistances will add up because they are slabs in series. So they are basically slabs in series, slabs in series. So therefore, you should consider the resistance formula for series. Remember, a slab has a thermal resistance. So resistance 1 plus resistance 2 is the effective resistance. These are your thermal resistance. Thermal resistance. And what is the formula for thermal resistance? If you have forgotten, it was length by K multiplied by area, L by K. Do you remember this? L by K was the formula. So resistance of 1 was thickness by K multiplied by area. Resistance of 2 was thickness by 2K multiplied by area. Resistance of the effective slab, the total length is 2A, area is still going to be A only, and this is K effective. A gets cancelled. So I'm left with 1 by K plus 1 by 2K is 2 by KE. This will be 3 by 2K is equal to 2 by KE. Therefore, cross multiplying, K will be 2 multiplied by 2K divided by 3. So this will be 4K divided by 3. That is your effective K. So 4K by 3, which is B option. Yeah. So you can treat these slabs like resistors having thermal resistances, just like how you solve resistor problems for series, you will solve the same way. You can use parallel formula if the slabs were placed one beside the other. Moving on to the next one. What is the dimensional formula of water equivalent of a body? Guys, this is so simple. You should be able to get it. Yeah, this is very, very simple, guys. Water equivalent. Water equivalent, the definition is the mass of water that absorbs the same heat for the same change of temperature as that of the body. So if you have copper, if you give some heat, it increases its temperature. Now you take some amount of water, and that water which will absorb the same heat, so that it replicates the behavior of copper by changing its temperature by the same amount. That amount of water that you took is called the water equivalent. So instead of copper, you can use that water. Heat wise, it will behave the same way. It could be wood, it could be marble, it could be anything. So you're replacing the material with water. So how much mass of the water? So this is basically mass. That's it, mass raised to 1. So D. That's it. There is only one dimension which will be there, and that is just mass, nothing else. Cool. It is very simple. Next one. The metallic rod is stretched to double its length, then the thermal conductance will become thermal conductance, resistance, conductance. Okay, come on, guys. So thermal conductance is 1 by thermal resistance, and thermal resistance is length by Ka. But wait a minute, when you stretch it, the length will double, but the area will also change because the volume has to remain conserved. So this is a question on volume conservation as well. So if you double its length, the area will become smaller. So the volume will be conserved. Volume is definitely constant. So earlier the area was A, length was L. The length has become 2L, area will become half, because we know area multiplied by the length is equal to the volume. So if the length doubles, the area has to go down. If it doubles, area will become half. If it triples, it will become 1/3. So clearly over here, what will happen is the new thermal conductance, the new thermal conductance will be K, area will be A by 2, and length will be nothing but 2L, length will be nothing but 2L. So this will be nothing but 1 by 4 Ka by L. So what is this Ka by L? Our old, our old thermal conductance. So it has become 1/4. What has it become? 1/4. 1/4 of its original value. Remains unchanged, half, quadrupled, 1/4 of its not original length. This was supposed to be 1/4. 1/4 of its original, not length, just original. So the correct answer over here should be D. Everybody understood? Clear? Very good. Excellent, guys. Yep. D for doctor. Proud of all of you. Very good. Very good. Moving on to the next question on your screen. The temperature of a body on the Kelvin scale is X. When measured in the Fahrenheit, it is found to be X Fahrenheit, then X is. Basically, the question is, what is that temperature which is same on Kelvin as well as Fahrenheit? Like for Celsius and Fahrenheit, I know it is -40. -40 Celsius is also -40 Fahrenheit. So what Kelvin is that same value in Fahrenheit? So you can go by simple logic that for any temperature scale, the temperature at boiling point minus temperature at freezing point of water upon what you can take is like the temperature difference. The temperature difference in that other scale will be basically a constant. This is what you can do. Yeah, or the temperature in general you can put over here. The general temperature minus temperature at freezing is delta T. This delta T you can then replace it by temperature at boiling minus temperature at freezing. So this is generally a constant for any temperature scale. So this is any random temperature. So first let's take the Kelvin scale. In Kelvin scale, let's say it is X Kelvin. Freezing in Kelvin happens at 273 Kelvin. Boiling is at 373 and freezing is at 273. And the difference is exactly 100 Kelvin. Whereas if you take the Fahrenheit scale, I don't know how many Fahrenheit it is. Freezing, what does freezing happen at? At 32. 32 Fahrenheit is 0 degrees Celsius, freezing point of water. Boiling and freezing point, guys, yes, what's the difference? What's the difference between them in Fahrenheit scale? Yeah, what is the difference? Come on, my dear students. This is 212 and this is 32. Yeah, that is what it is. So this difference is basically 180 and this difference is basically 100. Now just solve for x and you will get the answer. Just solve for x and you will get the answer. Just check it out. How much is the answer that you are getting? Yeah. So the answer that you get is 574, I guess. Just check it out. 574.25. So essentially what it means is 574.25 Kelvin is 574.25 degree Fahrenheit. So this is where the scales meet and you will get the same value. It's a very high temperature. Moving on to the next question on your screen. Two rods of certain length conductivities are connected end to end. If the cross-sectional are equal, equivalent conductance of the system will be equivalent conductance. This is just like the previous problem with what we did. Yes, the series problem. The series problem. Two rods of length L and 2L it is. So be careful. One rod is of length L, the other rod is of double the length. Conductivities are different. Be little careful. This is L, this is 2L, this is K, this is 2K. So when you replace it with one single rod, the total length will be obviously 3L And thermal conductivity effective, I do not know. Cross sectionals are equal. What is the conductivity of the system? So resistors in series. So R1 plus R2 is the effective resistance. First resistance is L by K. Sorry, this is K and this is 2K. My bad, guys. One second. Let me change it. This is 2K and this was K. This was K. 2K and K. L and 2L, 2K and K. Okay. So length was L, K is 2K, area is A, plus second resistance, length is 2L, K is K, area is A only. Resistance equivalent will be total length, which is 3L divided by K effective multiplied by A. A got cancelled, L got cancelled. So 1 by 2K plus 2 by K is equal to 3 by effective K. So this will become, yeah, 2, 2. So this will become 4. 4 plus 1 is 5. So 5 by 2K is 3 by KE. So KE, take it on the top, 3 multiplied by 2K, whole thing divided by 5, which is 6 by 5 times of K, which is 1.2 times of K. So that is your effective thermal conductivity, which is option A. Awesome. Perfect. Brilliant, brilliant, brilliant. Next one coming up on your screen. If there is a solid sphere of copper, hollow sphere of same material, inner radius R and outer radius is same as the first one. So imagine a solid sphere and another sphere is hollow, same size but different material. It is hollow on the other side, the other one. Material is also different. Same temperature and allowed to coil, no, I think it is cool. In the same environment, the hollow sphere cools faster than the solid sphere. Rate of cooling is according to the Stephen's law, which is T raised to 4. Now, yes, what will you do in this particular case? See, if you talk about the total rate at which heat will be emitted, that will be E sigma area temperature of that body raised to 4 minus temperature of the surrounding raised to 4. Now this dq by dt, dq is nothing but mass into specific heat into the change of the temperature, This dt will come over here as it is. It will be E sigma A, this is Stephen's law, temperature of the body raised to 4 minus surrounding raised to 4. Now dt by dt, I can take it over here. So dt by dt is equal to E is there, okay, divided by M and C is there. And then you have sigma A T raised to 4 minus Ts raised to 4. Sigma is the Stephen's constant. Obviously, it is the same for both of the body. So this is a standard constant. Area is 4 pi r square, which is the surface area, which is also the same for both. It is same for both the bodies. Temperature is same, surrounding is also same. So that is also going to be the same for both of them. Only E and MC is different. One is a copper sphere. Oh, the material is the same. If the material is the same, then E is also same. My bad. So E is also going to be the same. So M and C will be different or same. Even C will be the same because same material. Same material means C will be same. Only mass will be different. Only mass will be different. So who will have more mass? That change of temperature will be slower. So the one whose mass is more, M is more, it's in the denominator, dt by dt is less. And dt by dt means the rate at which it cools, how quickly the temperature changes. What is the rate of change of temperature? So whose mass is more? Whose mass is more? Obviously the solid sphere. So the cooling will be less. So the hollow sphere cools faster as compared to the solid sphere. Isn't the assertion correct? So definitely it is correct. So such a crazy assertion reason question. Thank you, Krutika. Yes, such a crazy question, guys, where we had to do this analysis. You cannot just randomly guess it out of the box, right? Rate of cooling according to Stephen's law is T raised to 4. What nonsense. I have written such a big thing. Rate of cooling is according to Stephen's law, which is what is T raised to 4? No, what happened to E, sigma, A? Oh my God. And what happened to M and C? Nothing they have put. So guys, obviously reason is false. That is false. So assertion is true, reason is false. They did not give the law completely. Yeah, they did not give the law. They did not just give it completely. Stephen's law is not just the rate of cooling is T raised to 4. Who said that is the Stephen's law? It says the rate at which the heat is radiated per unit time per unit area is proportional to T raised to 4 for a black body. That is Stephen's law. Then when you take a normal body, then E comes. Then when you count for surrounding, then this will also come. And then when you count the rate of cooling, then you have to put MC delta T. So many things are there. So all those things they are just casually, they, yeah, skipped it. Two square rods welded end to end. First one, 20 calories of heat flows through it in 4 minutes. If the rods are welded as shown in figure 2, the same amount of heat will flow in how much time? Ayyo, it's a lengthy question because the one is series, one is parallel, so things will change. Okay, so think like this. This is like one resistor. I'm going to make it simple for you. This is R, this is R. So here the resistance is 2R. Here, think of this like resistance. Each of them is R. So the effective resistance will be R by 2. Reason this is series, this is parallel. And we know that the heat flow rate or heat flow current, the current is the voltage by resistance, but in thermal physics, the heat current, the heat current, the heat current is the temperature difference by the resistance. By the resistance. Is the temperature difference the same? 0, 100, 0, 100. Oh yes, the temperature difference is 100 minus 0, which is basically the same for both. So the one with more resistance will have less heat current and vice versa. And heat current is nothing but how much heat flows per unit time. Okay, so since delta T is same, I can say heat by time multiplied by resistance, which will give me delta T is going to be the same for both of them. So heat, how much heat goes, the same amount of heat will flow, same heat. So Q, time for the first guy, 4 minutes. Resistance in the first case, 2R. In the second case, same heat, so Q, time I do not know. Resistance in the second case, R by 2. R cancels, 2 and 4 cancels, it will become just 1 by 2 is equal to 2T. So 2 cancels, 1 is equal to 1 by T. Therefore, T is equal to 1 minute, which is A option, guys. Perfect. So 1 minute is the answer. How many of you got it as 1 minute? Did you love the question? Very different question. Yeah, based on thermal physics. Yeah, sorry, based on heat transfer, conductivity. No, it is not C. It is option A. Correct. 2 and 4 cancelled, became 1 by 2. So this was 2. T will be remaining. Q cancelled. That's all. What a brilliant question, isn't it? So imagine these questions are going to come and there will be lakhs, and not 1, 2 lakhs, 3 lakhs, 4 lakhs. I'm telling you, 10 lakh plus students will leave this question. Can you imagine the amount of insanity that is going to be there? 10 lakh plus students. I'm not even kidding. Many students will be even not bothered to study physics properly. They will just study some random YouTubers, study 10 topics and you will get 160 marks. Study 5 topics and you will get 120 marks. Impossible in this 2025. Impossible in 2025. I'm telling you this. And then when these kind of questions come, there is no point of just studying NCERT. NCERT, sir, I have by-hearted it for physics. Very good. I'll clap hands for you. I will bring 100 people for you and they will all clap hands because you have by-hearted NCERT. There is no use of by-hearting NCERT. if you can't solve this problem. So that is why problem solving, guys, very important. Coming up on your screen, this is very interesting. Volume temperature graph is there. Match the columns 1 and 2. That's all. Match the columns. Let's see how many of you can do this. Brilliant question. Come on, guys. What are you going to do? Gas is mono, dia, Na by Nb, Pa by Pb, gas B is volume and temperature. Volume temperature graph is linear. So what does this tell you? Volume by temperature is basically a constant. PV is equal to nRT. So from that, if you compare, PV is equal to nRT. If you just compare this, volume by temperature will be nothing but nR by P. Oh, so nR by B is nothing but constant. Okay. So R is anyways a constant. That means N by P is nothing but a constant. So from this, what can you tell? If N by P is a constant, can you tell me whose pressure is more or less? Oh no, I don't know whose moles are more or whose moles are less. I cannot tell. Even Na by Nb, I cannot tell. How can I tell whether it is mono or dia? It is not even mentioned about how much heat or work or anything like that. No, I don't think I can get anything. Nothing can be said. I feel T, 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 T. I feel the answer is C. Oh my God, look at it. Nothing can be said. Imagine this question comes in NEET 2025, similar type or exactly the same, where all the options point to one thing cannot be said. Imagine how tough it will be to mark in the actual examination. You will doubt yourself so much that maybe I'm doing something wrong. How is the answer cannot say anything? Maybe I do not know something. You will doubt yourself, but you will not doubt the paper setter. And you will be like, no, no, something is wrong. I have to think something. And chumma, you will apply some logic and some answer you will get. But no, the answer is nothing can be said. So that is the brilliant thing about this question. Okay, the root mean square of oxygen and at a certain absolute temperature is V. The temperature is doubled, the oxygen gas dissociates into atomic oxygen. What do you think the RMS speed will be? Interesting. So the gas has dissociated and O2 is a diatomic molecule. The temperature is doubled, oxygen gas dissociates into atomic oxygen. We know that the RMS speed is nothing but root of 3RT by M. Essentially, it is proportional to root of T by M. So, V2 by V1 is nothing but T2 by T1 under the root, and here we'll have M1 by M2. So, the new speed I do not know, the old speed I know is V. The temperature has been doubled, so 2T by T. It dissociates, so into atomic oxygen. So first mass by second mass, this will be in the ratio of 2:1, right? So the first mass will be double of the next times mass, right? This will be 2m, this will be 1 time of m, atomic oxygen. Make sense? So this will be root 2 into root 2, which will be just 2. So V2 will be 2 times of V. 2 times of V is C option, I believe. That is, yeah, Captain Shreyas. Perfect. Again, amazing question. Usually these questions had root of T proportional. Usually we do not see questions where root of M is also there, but this is one such question. And the best part is the gases were not different. It was the same gas, just that the diatomic gas has split into monoatomic gas. That's all. So atomic mass number has changed. So M being the atomic mass of that particular gas. Okay. Sir, please explain the previous question. Which one? This one. See over here, if it was the same mole, example, it was the same number of moles, then N is also same, then I can just say over here, just think about it like this, over here, this VT, V by T, which is there, what will be V by T? Think about it, V by T will be nothing but NR by P, which is nothing but the slope, which is nothing but a constant. In any one of them, that slope is constant. Is that what you are seeing? So imagine moles were same. Then what will you say? The one which has more slope has lesser pressure. The one which has less slope has more pressure. So you would be able to compare the pressures, right? Easily. But now, number of moles are not same. It might be different and nothing is mentioned about it. So I can't I can't say is Na more than Nb? I don't know. Is Na less than Nb? I don't know. Is Na equal to Nb? I do not know. So can I tell anything about moles? Definitely cannot say anything. If I cannot say anything about the moles, can I compare the pressure of A and pressure of B? Is there any equality, inequality which I can put? The answer is no. It is again a questionable thing because I cannot say anything about the pressure because I don't know the moles, even though if I know the slopes. So that is the reason why I cannot say anything. And to predict whether it is mono or dia, I need to know some other information also, right? Like work by heat or some other thing. Nothing as such has been mentioned. The gas type, nothing is mentioned. So how can I tell it? Okay, got it? Yeah. The gamma, I don't know anything about the gamma. Even for mono, the gas might be showing the same graph. Dia also, it might be showing the same kind of graph because at the end of the day, this graph does not have any gamma in the formula. So the information of gamma will never come from volume temperature graph if it is a straight line. I will never know whether it is mono or dio. Okay, cool. Let's go to the next one. There is a perfect gas, that means ideal gas, heated at a constant pressure. So the volume will double, the increase in the temperature of the gas will be. Okay, come on. So temperature is going to change, pressure is going to definitely change. Sorry, pressure is same, a volume is going to change. So doubling its volume. So constant pressure, guys, P is a constant. So definitely volume by temperature is going to be a constant, correct? PV is nRT. So volume by temperature is constant. So original volume V, original temperature 300, final volume doubling it. So final temperature I do not know. So therefore the temperature will be 2 into 300. 2 into 300, VV got cancelled. So it will be 600, but obviously it will be in Kelvin. But I want it in Celsius. So 600 Kelvin minus 273. So that will be in degree centigrade. So our temperature will be nothing but how much? 327. 327 degrees Celsius. So, oops, no, not 300, guys. 327 degrees Celsius. It is wrongly marked as 300. So, yes, it should be 327. Is this clear, my dear students? Everybody with me on this? Everybody? Okay. Remember, always temperatures are measured in Kelvin. Yep, yep, yep. Always temperatures are measured in Kelvin. Do not make that mistake. Correct. So, the correct answer for this is going to be biology. By mistake, I think they have put it as D. That is not correct. Moving to the next one on your screen. Which of the following graphs represents the behavior of an ideal gas? Of an ideal gas. Okay, come on. This is straightforward now. As O2 splits into monoatomic, weather will not change means what do you mean by weather will not change? What is asked? The increase in the temperature is asked. Okay. So if increase in the temperature is asked, then the answer will be 300. Yes. If delta T is asked, so it will be 327 degrees Celsius minus originally it was 27 degrees Celsius. So it will be obviously then 300 degrees Celsius. So then option D is correct. Yes, the increase in the temperature is asked. Perfect. Yeah, the answer is going to be uh, D only then. Yeah, my bad. Which of the following graphs represents the behavior of an ideal gas? When pressure is constant, is this the graph that you get? Come on. The gamma is not even there. The previous question, if the temperature is, why is gamma there? Well, one in RMS speed formula, why is gamma there? You are getting confused. That gamma is there in the speed of sound. Speed of sound has that formula, which is gamma RT by M. That is sound of speed, not RMS speed. You got confused. RMS speed never has gamma in that formula. Even most probable or average speed does not have gamma. So I agree, gamma will change, but gamma has no effect on the RMS. The speed of sound definitely would have changed. But the question is not on the speed of sound. Is that okay? Good, you asked that question. I hope that confusion is clear. Oh yes, this is definitely the case, because volume by temperature is nr by p when your pressure is going to be constant. Definitely A option is correct. Pressure volume isothermal graph has to be like this, guys. I mean, what nonsense. This has to be like this. So this is definitely not correct. This is definitely not correct. So once the one of the option is checked, you don't even have to check the other options. Pressure into volume versus temperature. Is it a straight line? PV is equal to nRT. So by T, PV by T is basically nR. So pressure pre pressure volume is on the x-axis. So you can see that pressure volume is, sorry, on the y-axis is proportional to the temperature. So it is proportional to the temperature because N into R is a constant for a gas. So it has to be a straight line, but with like this. So obviously this is wrong then. This is also wrong. And pressure volume versus temperature has to be a straight line. It can't be a curved line. So this is also wrong. So D option also goes wrong. Is that clear now? Okay, I hope Valvan that previous question was clear and you said that. Okay, great. At what temperature is the RMS speed of hydrogen equal to that of oxygen at 47 degrees Celsius? Interesting question. Let's see if you can do it. RMS speed of hydrogen equal to that of oxygen. Okay, come on guys, use 3RT by M formula. Use 3RT by M. Yes. So RMS speed of hydrogen is equal to RMS speed of oxygen. So temperature we have to find. So 3RT divided by hydrogen molecular mass 2, oxygen, this is 3RT, oxygen molecule at 47 degrees Celsius. So I believe this is 320 then. The whole thing divided by, for oxygen, it is nothing but 32. RRT 3 cancels. So root of T, even this 2 and 32 will cancel. Actually, this 32 and 32 will cancel. Okay. So I have T multiplied by 10. 32 has cancelled. Wait, something I made a mistake. I shouldn't have put T here because I already put temperature. Sorry, yes, my bad. I've already put temperature, which is 320. Okay, so that's it now. So remove the roots. So T by 2 is equal to 10. Therefore, T is equal to 20. So T is equal to 20 Kelvin. Everything is in Kelvin. So B option should be the right answer. Perfect. That is the correct answer. Very good. Hi, Sangeeta. I hope you're doing great. Long time. The average translational kinetic energy of a molecule of a gas for different gases at the same temperature is the same. Is this true or false? The average translational kinetic energy per molecule for different mono, dia, poly, whatever, yes, it is 3 by 2 kT. So this is definitely correct. Nothing wrong in it. Using law of equipartition. At a given temperature, all molecules move with nearly the same speed. This violates our assumption of KTG. That is wrong. Every molecule will have different speeds. Most of the molecules will have nearly the same speed. It's not all the molecules. Many molecules will have nearly the same speed. So one is correct, two is false. Option C is the correct answer. Is that okay, everybody? Let's move to the next. Oops, this was direct anyways. Even if you do not, I mean, solve this, it's fine because you would have solved this 100 times now. RMS, average and most probable. What is the comparison between them? See, the formulas you should know. For RMS, it is nothing but 3RT by M. Then for your average, it is 8 by pi RT by M. This 8 by pi is less than 3, but it is more than 2. It is 2 point something. And your most probable is basically 2 times RT by M. So since the number 3 is more than the number 8 by pi is more than the number 2, because this number 8 by pi is 2 point something. So therefore, RMS is always more than average is a more than most probable speed. These three formulas you should know. Yeah, RMS more than average, more than most probable. The ratio Cp by Cv for a diatomic gas is more than double. Think about it. For a monatomic gas, the molecules of a mono gas have less degree of freedom than those of diatomic gas. This is again straightforward, guys. Come on. Is it more than double? Cp by Cv for a diatomic gas, how much is it? It's 7 by 5. And for a monoatomic gas, it is 5 by 3. This is nothing but 1.67. Correct? And this is nothing but 1.4. How is it double, guys? How is it double? For a diatomic gas is more than that. No, not double. A diatomic gas is more than that for a monoatomic gas. No, Cp by Cv for a dia, how is it basically more than that of a mono? Definitely wrong. So this is wrong. You can see 1.4 is less. The molecules of a mono gas have less degree of freedom than that of a diatomic gas. Yes, for a monoatomic gas, the degrees of freedom is 3. For a diatomic gas, the degrees of freedom is 5, excluding the vibration. So this have less degree of freedom. So the reason is fine. But how is it even explaining the assertion? And assertion itself is false. So assertion is false. The reason is true. D for doctor. Correct. Yeah. Is that okay, everyone? Let's go to the next question on your screen. If there is a gas which is found to obey the law, P raised to 2 into V is constant, initial volume and temperature are given, T0 and V0. If the volume is now changing, what is the final temperature going to be? Interesting. I think pressure is irrelevant here. So let's try to get rid of pressure. These kind of questions have to be solved that way. So P raised to 2 into V is a constant. Now pressure is nothing but nRT by volume. The whole thing raised to 2 into volume is nothing but a constant. So n square R square T square V by V square is a constant. But we all know nr are constants. So this will become temperature, Vv will cancel, is equal to a new constant, I can say. So once I get this, I can solve the question. The original temperature was T0, so raised to 2. Original volume was V0. Final temperature, I do not know. Final volume is nothing but 3V0. So V0 cancels, 3 goes on the other side. So therefore 3 times T0 square is basically T. So T square. So T is nothing but taking roots on both sides. Root 3 multiplied by T0. Root 3 multiplied by T0, that is the D option. Perfect. That's how I solve it. So these kind of questions, you just need to manipulate it such that random things are not there, like pressure. Pressure had no role to play. So I got rid of pressure. I got the equation only in temperature and volume. N are constant, so I made it into a new constant. Volume had anyways got cancelled. Is that okay, everyone? Shall we solve the next question on your screen? Here it is. The pressure of a vessel is reduced by drawing out some of the gas, the mean free path of the molecules. Guys, this is simple. What is the formula for mean free path? Come on. Everybody should remember this. N is there on the top. Root 2 is there. Pi is there. Diameter square is there. And here you have volume. Is that right? Mean free path. Oh, sorry. Volume is there on the top. Number is there below. My bad. Volume is there on the top. N is there over here. Yes. How many of you remember this? If the number of molecules increase, the mean free path will reduce. If the volume of the container becomes large, they will have more space. so mean free path will increase. So now, if you have the same vessel, that means this is same, this is same because the vessel is the same, but you are taking out some of the molecules. So the value of n will decrease. So the mean free path obviously should rise. So the mean free path will be increased. Option A. Direct formula based question. Direct formula based. Next one on your screen. Two different isotherms are there. This is an isotherm, this is an isotherm. One is for mass M1, one is for ideal gas of mass M2, I think, are shown for masses M1 and M2. But for the same gas, same ideal gas, whatever, if it is oxygen, but different amounts of oxygen are taken, I believe. So which one of them will be correct? Now, think like this. Think like this. PV is equal to nRT. Number of moles is mass of the gas by the molecular weight into RT. So that is what it is. So P is equal to M, okay, RT by capital M, and this is V. Imagine I consider the same volume. Imagine I consider the same volume and then I'm trying to compare. Just see, volume is same, gas is same, this is universal constant, isotherm, so temperature is same. All these things are going to be the same. Everybody with me on this? So now quickly analyze the one gas which is showing more pressure out of these two. The one gas which is showing more pressure, obviously P2 is more than P1, will also have more mass. So P2 more than P1. So M2 will be more than M1. Is that clear? M2 will be more than M1. Very simple analysis, guys. And that's why C option is the correct answer. So I've just taken the comparison at same volume. I've just used the ideal gas equation, but the moles is mass of the gas upon the molar mass. Molar mass same, volume same, R same, T same. So direct relation you can get. What a brilliant way to analyze the question. Very different new things you are learning today. For a sample of an gas which occupies some volume at some pressure and absolute temperature, the mass of each molecule of the gas is m. Which of the following gives the density of the gas? Density of the gas. Come on, guys. Everybody knows this. Which of the following gives the density of that gas? Occupies a volume, pressure is P, temperature T, mass of each molecule is small m. Which of the following gives the density of that particular gas? We all know that pressure into molar mass, Pm, is rho RT. We want density. So density is pressure into molar mass divided by R into T. But I don't want R, I can see some K over here. And we all know the value of K is nothing but R by Na. R by Na. So instead of R, put this as K multiplied by Na. Just put it as K multiplied by Na. Things will get sorted. T is there, P is there, M is there. But I don't like it like this. So P and then K and then T, and then you write it as M by Na. What is the use of writing it as M by Na? The advantage is this will become molar mass divided by Avogadro number, which is the mass of each molecule, which is nothing but small m. Yes, that is nothing but small m. Is that clear? This is the mass of each molecule. This is the mass of a mole. That is why molar mass. So a molar mass divided by the Avogadro's number will give you mass of each molecule. So Pm by Kt. Pm by Kt is B option, as you can see. Pm by Kt is B option. This is ideal gas equation in the density form. Pm is rho RT. Yes. Loving the questions. Wow, very nice, Pratibha. Great, great, great. So just trying my best to make sure that, yeah, everybody gets the best of the best of the best questions. All right. Moving to the next one. According to the law, energy associated with each molecule per degree of freedom. I think this was very simple, I guess. There is nothing great. Per degree of freedom, per molecule is half kT. That's it. Directly half kT. I think it's not mentioned here, but yeah, the answer is half kT. This is your law of equipartition of energy directly. Let's go to the next question. The temperature of a gas increases from this to this, the percentage change in the RMS velocity. Very crazy question. Why? Maybe. Let's see. Velocity is proportional to root of temperature, RMS wise. So velocity has changed. So the new velocity by the old velocity will be root of the new temperature by the old temperature. The new temperature 127, that is 400. The old temperature 300. So this is root of 4 by 3, which is 2 by root 3. So this is V2, this is V1. So V2 is V1 2 times by root 3. But what do I do now? The question is the percentage change in the RMS velocity. So to find that, that is equal to the change divided by initial, the whole thing multiplied by 100. That's how you calculate percentages. So the change is nothing but V2 minus V1. Original is V1. The whole thing multiplied by 100, that is in percentage. V2 is 2 times of V1 by root 3 minus V1 by V1 multiplied by 100 in percentage. V1, V1, V1 gets cancelled. So 2 by root 3 minus 1, the whole thing multiplied by 100. Now calculate this, guys. How much is it coming out to be? So this is 2 by 1.73 approximately minus 1. The whole thing into 100. Just get a rough idea. How much is it coming out to be? Yeah. Come on, guys. 1.73 is like, I can say 1.7 is 17 by 10. So 0 goes on the top, 20 by 17. Come on, 20 by 17, roughly, how much will it be? 20 by 17, 1.17 times, something like that. Okay, minus 1 is 0.17. So close to 17%, but I have ignored that second decimal. So I think it will be slightly less than 17%, around some 15-16% it should be. It won't be this huge. It won't be 11%. It will be close to D. Yes, that is the correct option. Okay. Just check it out. If it comes out, yep, this should come out roughly 15.5%. Is that okay, everyone? Yep, very good. Excellent. Moving on to the next question on your screen. When a system is taken from state A to state B along the path ACB, heat is 200 by the system which is absorbed, work is 80 done by it. Along the path ADB, heat is this much, UA is this much. What is the value of UB? Okay, if already path ACB is given, why do I need that other path? Irrespective of the path, the delta U will be the same. So delta U, it is found that a quantity of heat which is absorbed by the system and work done is done by it. So delta U, which is heat minus W, heat is absorbed, so it is plus 200, and work is done by it, that means that is positive 80. So this is nothing but 120 joules. Change in energy is UB minus UA. That's it, final minus initial. So UB minus UA. Therefore, UB will be UA plus 120. Original energy was 40, so plus 120. So that will be 160. So that's it. It is the D option. Yep, nothing great. So you might be wondering, sir, what is the use of these things? What is the use of these things along this path? Useless. Chumma they have given to confuse you. Okay, whether you go from this path, that path, internal energy changes are always the same. It's a state function. Yeah, it is just going to be D option. Correct? Very good. Perfect. Let's go to the next one. Sample of an ideal gas undergoes isothermal expansion and represents heat change, work done. Then what do you think is the correct thing? What is happening? Undergoes isothermal. Isothermal means temperature is going to be constant. So internal energy will not change. So du should be 0. Is that right? Du will be 0. That's it. There is no other option with du 0. Directly mark B option, be the smart one here. That's it. You don't even have to check anything else. But anyways, if you check also, what will happen? If it undergoes expansion, that is very clear. It is undergoing expansion. So work done will be positive. So if work done is positive here, okay, heat will also be positive because delta U is 0. So whatever heat is being given will be converted into work. So B option is the most perfect option. Next one. There is some air compressed, suddenly the temperature will be. What do you think the temperature will be? Come on. If it is compressed suddenly, some quantity of air at 27 degrees Celsius, if you compress it, what do you think will happen? Yes, if you expand, it cools. If you compress, it will warm up. So the temperature has to rise. This is there as an example also, reversible, irreversible processes, right? So when you see a tire bursting, suddenly the pressure which was stored in it gets freed up and it comes to normal atmospheric pressure. In this process, the gas cools down, right? Suddenly. So there is a loss of internal energy, which is converted into work. And when you do the exact opposite, when you're compressing it, the work done is negative, right? So work is done on the gas. So all that work which is done on the gas will be stored in the internal energy. So internal energy increases means temperature will increase because heat will not be absorbed. It is a sudden process. So Q will be 0. So you can go by law of thermodynamics also. Q is delta U plus work. So whatever work is done is going into the internal energy change. So work is done on the gas because it is compressed. So W is negative. So delta U will be positive. Is that okay? So that their sum will be 0. It's a sudden process, so adiabatic. Very straightforward. Great. Good evening, Sukumar. Yes, B for biology. Moving on to the next question. The molecular weight of O2 and H2 are 32 and 2 respectively, and the ratio of the RMS speeds are at the same temperature. This is simple, guys. Velocity is inversely proportional to the root of molecular mass. So the ratio of the speeds of what? O2 upon H2. So for oxygen, it is 32. For hydrogen, it is 2. So root of 1 by 16, which means 1 by 4. So 1 by 4 is C option, not 4 by 1. I think it is H2 and oxygen. I think they have asked H2 by O2. Yes, then it is fine. Velocity of hydrogen by oxygen will be 4 by 1. 4 by 1. So then option A will be correct because they have asked hydrogen first and then oxygen. So hydrogen by oxygen will be 4 is to 1. Yeah, very, very simple, straightforward question. Cool. Moving on to the next one on your screen. There is a mixture of 3 moles of oxygen, 5 moles of argon. Considering only translation and rotational modes, the total internal energy will be. So the total internal energy of the gas will be the internal energy. First, what is it? 3 moles of oxygen plus argon. Now, oxygen is a diatomic. This is monoatomic gas. Keep that in mind. So internal energy is NCVT. Number of moles of oxygen is 3. For diatomic, it is 5 by 2 RT. And this is argon. This is 5 moles. And monoatomic, obviously, it's an inert gas. So the CV value for it is 3 by 2 RT. Okay, perfect. So what do we have over here? 3 5s are 15 plus 15, the whole thing by 2 multiplied by RT, which is 30 by 2, which is again just 15 times of RT, which is option number A, which is option number A. Direct question. Very good. Awesome. Moving on to the next one. Ideal gas follows the process PT is constant, then the correct graph between them is pressure into temperature is constant. You'll be like, oh, what is this, sir? Pressure into temperature is constant. Don't get scared by it. Yeah, don't get scared by it. See, they have asked pressure versus volume, right? So get rid of temperature. PV is nRT, so temperature is pressure into volume by nR. So get rid of temperature. So this is going to be constant using ideal gas equation. So this will become P square into V is nR multiplied by constant. That means P square V is a new constant. Oh, this is just like saying P into V raised to half is a new constant. Oh, this is like PV raised to gamma, guys. PV raised to gamma, we already know how the graph looks like. It looks like this. So P is basically inversely related to root of volume. So it should be like this. So option C is the correct one. Yeah, everybody, this is like PV raised to gamma. Gamma is like half over here. So that's it. That is the answer for it. Cool. Great. Okay. So I think last one or two questions are there. I think we can do it as homework. So I want to see whether you can solve this. 300 ml of gas cooled to 7 at constant pressure, then the final volume, guys. Come on, everybody should be able to do this. Isobaric process, this is constant over here. So when pressure is constant, we know volume is directly proportional to the temperature. So please take it up as homework now. Yeah, please solve this as homework. The answer I will be providing in the PDF, which I'll be sharing shortly by tomorrow in the description box or in the comment section. Okay, so try to solve this as homework. I have already given you the hint. Yes, even this problem, take it as a homework. Outer faces are made of certain thicknesses and the temperatures are given. The temperature of the interface if the thermal conductivity is given. This is like again your series problem. One part is here, one part is here. This side temperature is 100, this is 0 degrees Celsius. Question is how many degrees Celsius is this? Yep, these are in series, and remember in series the current is the same, heat current. This is heat current, which is K A delta T by length. Yes, this is basically the same for both of them. Just equate it, you will get the answer. Just equate it, you will get the answer. Again, solve it like a homework problem. I have already given you the hint. Cool. So those were the amazing, amazing questions for all of you from the entire unit of thermal physics. I'm pretty sure it has opened your eyes and probably will make you to take this particular entire unit seriously and explore more questions. Don't worry, we are going to explore a lot of questions. We have little more than a month's time to explore all of this on this very own channel of yours, which is Vedantu NEET English. So make sure you are liking this video to show support and subscribe to the channel so that you do not miss any class even by mistake. Thank you so much. And of course, the NEET crash course is starting very soon, just a week later. So if you are not yet enrolled, already, some 200-300 students already are part of it, even before it has started a week before. So if you are missing out on it, please make sure you join this batch as soon as possible. Thank you so much, guys. Have a great time. Bye bye. Hasta la vista. Take care.